Okay, so today's video is going to be about lasers. Again, the worst color for this, I'll choose the bad colors. Laser. So we know that laser is nothing but light but monochromatic, or light but any single color of any single color of the 7 colors of light. But the most common is red, I think green and blue. By the way, there's a special name for the single color wavelength, the single color of a light. It's called monochromatic. Monochromatic. By monochromatic, I mean single frequency. Monochromatic means single frequency. Light or the color with only one frequency. That's called monochromatic. This is for, okay then. Here we'll be taking light. Yeah, one more important thing. Since I mostly talk about quantum mechanics, here I will be taking I will take light as particle. Okay, so now let's talk about the inner structure of the laser, which in full form of laser itself is the process. So this is inner structure, and everything what happens or what beam we get, this beam depends highly on the process which is happening inside the structure. Process in progress mean the process we have here, monochromatic light. Okay, now if I talk about laser itself, the full form of laser, by opening this full form we will get the process of laser, of how laser works. Okay, first of all, LA, light amplification. Okay, then S, stimulated emission. And of course there is radiation. Okay, if I zoom in to this L over here, if I zoom in, what I will be seeing is energy levels. energy levels E1 and E2. So sorry, it should be vice versa. It should be opposite because E1 is always taken as the lowest energy level, because E2 and E1. E1 is known as the lowest energy level. Okay, and this is the excited level, the one in which electron, yeah, one more thing, electrons will be playing a role over here. Electrons. So here what will happen is that this is called a lowest energy level, this is called the excited level. Excited level. Now what is the process? Light amplification. Okay, what will happen is that light, first of all we'll talk about light amplification. Let's suppose this is a photon, it is a photon, but photon is not my energy. Energy or wait, let me, I think this color is not visible, so I'll change the color and I'll make it okay, let's put, oh yeah, yellow is for light, photon, but I will be taking it as energy wave. Energy, okay. Now that's interesting thing. Here, if when I say it's particle, I'm talking about electron, not light, because light here we are taking the light itself whole as energy which is wave. So, or we can say in some manners, because this photon, when it will come and hit this electron, over here, or to be having a like normal thing, we'll say it's a particle. So why we will say it's particle, because same thing will happen. It's a particle. Okay, what will happen is that the photon's energy will be given, what's this, okay, given to the electron. Now here what will happen is that when electron, now electron has energy. First it was in the lowest state, it had no energy. Now it has energy. What it will do, it will jump up, it will have over here, it will now have energy. It will gain energy and bounce up to the next energy level, or it will jump up in a energy level. It will go first electron had had E1, but then it converted to E2. So how? E1 minus E2 will give you the energy of the photon. This is one way of calculating energy of photon, when you have the energy difference of from 1 to 2, or it should be 2 and 1, yeah, okay, over here. Then okay, let me write the equation over here for these two. I want to show something over here in terms of equation. So what I will show is that when this photon, this is, can I write it as E equal HF, right? Because in a photon is nothing but energy which is of a certain frequency. So what happens that when this energy is given to this kinetic, this electron, it will gain energy, gain energy, and again the same thing, it will jump up. Okay, now here there is one key point that we will talk about: light amplification, stimulated emission. For here there's a key point: stimulated emission. It means that even though this electron jumped up in level, but it won't stay there forever. Won't stay in the excited level for too long. The interval is only 10 to the power minus 8 seconds. Yeah, only 10 to the power minus 8 seconds. There are some assumptions, there are some exceptions in which there's a certain stage in which it can stay longer than the required time. That's most common time. I think it was called, what was the name of the stage? Stage, I forgot the stage name, but there is some certain levels. Okay, then what else? Yeah, over here, well, I told you that the energy, the photon which is in an excited state, won't stay there for a long time. It will come down. Here there is a key point, because without that point, or without that being happening, the light, the laser, in the end we won't get that. The point here is that stimulated emission, the emission of this electron going, out. There's one more key point I'll tell you later. The electron, the time, the number of electron which go down in energy level, or which the number of electron which decrease in energy level should be more. Okay, now here let me tell you why. Okay, if I write in equation terms, emission, stimulated, it's better words. Emission should be more than amplification. That should be a fact, and it is a fact. That's main, here I'll write main reason the lasers are given out, or the light, or the ray, this ray which is given out. That's because it will only depend on this dependent. Now, oh yeah, one more thing. Here, when this photon is giving energy to this electron, it goes up in level, but when it will decrease in level, same thing will happen. What will happen? Same thing will happen, that it will now, when it's decreasing, it will again give out electrons, or sorry, give out energy, which is photons. Okay, now there's one more thing as well, that time passes very fast. It's funny, right? So then what else was it? Yeah, if we take this whole thing, because how the structure of that the front part of the laser is that back part from where we get the laser. I'll show you. This is, okay, this is a mirror. This is mirror. Again, this is mirror. So what happens that over here this and so on and so on, the number of particles, number of electrons. Again, look at the key point. Again, one more point here. When I mean wrote the number of, or draw the number of electrons in the upper one and the bottom, did you notice that the number of electrons in the top is greater than the number of electrons in the bottom? As same reason, because of stimulated emission should be more than amplification. Okay, so then what I was saying that when this electron will go down in level, it will because how it will say that over here this electron will gain energy, it will jump up in level. Now it's here, now again it will come down, then over here there will be it will come down, it will emit photon. Okay, it will again emit photon, that photon will go again and maybe connect to and give energy to this photon, it will give energy to this photon, it will jump again in level. So what I say is that one single, not one will be too boring, single photon um, emitted by the electron in one electron in by the or emitted by emitted from one electron will cause a chain reaction, and this process over here, that stimulated emission should be greater than light amplification. This process is known as inverse population inversion. Okay, so the two mirrors over here, and this is what the main thing over here, this is called a medium, the medium in which everything is done. So the main thing here is that one electron. Okay, then the mirrors, what will the mirrors do? Mirrors job of, or let me make it another color, job of mirror is to reflect and keep the reaction ongoing. Then one more thing, the light we get, this ray, it is only 1% of the 100% of light itself. The whole process, we only get 1%. If this is not a fact, this is just what I think it is, so just don't take it as a main thing. This is what I think I heard of it, so keep this, you can say it's like a half known fact. So then what else, am I missing something? Am I missing something? Am I missing something? Light amplification. Ah, radiation. Radiation is nothing but the light again. If I talk about, wait, I have space here. I don't want to just go to another page. Radiation. Radiation is nothing but the single uh, 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 the ray of chromatic light. The ray of chromatic light is radiation. The further after that, what happens in the end is radiation. And yeah, that's it. Thank you.